Okay, so in this video we're going to look at algebraic fractions. So it's important to understand the difference between expressions and equations. So equations contain an equals, so the EQUA equation with the equals, and expressions do not have an equals. The implication for us is that in an expression we are not able to get rid of the fraction like we would if it was an equation. So we have to manage the fraction. So it's really important before you start a question that has fractions that you understand if it is an equation, so if there is an equals there, or if it is an expression. So this video we're specifically looking at expressions. And when we get fractions in an expression, the things that we might be asked to do are simplify. So that's to make it simpler. So there usually involves some factorization here. We can be asked to add or subtract fractions. We can be asked to multiply or divide fractions. And we can be asked to simplify complex fractions. So complex fractions are fractions within fractions. So they sometimes look quite scary, but usually they can be split into just multiplying, dividing, adding, subtraction. So they're really a mix of adding, subtracting, multiplying and dividing. So the first example we're going to look at then is a simplify. So we have a fraction here, it's an algebraic fraction. We have x's above and below the line. So in order to simplify, we must first break it down into the building blocks to see is there anything common above and below the line. And for us, this means that we have to factorize both the top and the bottom line. The easiest way I think that you can do this is by separating out the lines. It can become quite messy if you try to keep it in a fraction. So the method that I'm going to use here is taking the top line, working with it, taking the bottom line, working with it, and then putting it back together at the end. So the first thing I'm going to do is we're going to label, so the top line and the bottom line, and we'll take out this top line here. So we have x to the power of 3 plus 7x squared plus 12x. So if you were unsure about your factorization, there is a video uploaded which goes through all the different types of factorization. This factorization here may look somewhat like a quadratic, however, it's not exactly a quadratic because it has an x to the power of 3. And quadratics we deal with have an x squared as the biggest power in the expression. So we need to look at our other types of factorization. So if we run through them, is there anything common to all terms? So highest common factor, and the answer is yes, there is an x common to all three terms. So we'll take that out. So that's my first type of factorization. So I'll take out an x and I'm left with an x squared plus 7x plus 12. Now it's important to notice at this point that you now have a quadratic in the bracket. So in the factorization video we looked at where there was multiple steps for factorization. So where one type of factorization was not enough, and this is a good example of that. So we now have a quadratic. So we're going to use the guide number method. The guide number we have is the 1 by plus 12, which just gives me plus 12, and the factors are both going to be the same sign because it's a plus 12. We need to get them to add to plus 7, so we get plus 3 and plus 4. So at this point I'm just going to start using square brackets just to ensure we don't get confused with the brackets where they start and where they end. So I've rewritten my 7x here as plus 3x plus 4x. So now I'm going to do my grouping. So in the first two terms, x squared plus 3x, an x is common, and in the second set, a 4 is common. So now my check for this is, are my brackets the same? Yes, they are. They're both x plus 3. So they are now common. So I'll pull those out and it leaves me with an x plus 4. So to clean that up, we'll just drop those square brackets. They're not required anymore. And that is the top line fully factorized. So let's move on to the bottom line then. Here we have a straightforward quadratic. We have an x squared, an x, and a number. So our guide number here is minus 3. To factorize it to give us a plus 2, we're going to use plus 3 and a minus 1. So we've just again now rewritten our plus 2x as minus 1x plus 3x. The order here, if you wrote a plus 3x minus 1x, it should still work and there will be no issue. So in the first two, x squared minus 1x, there's an x common, and that leaves me with x minus 1. In our second group here, there's a 3 common, and that leaves me with x minus 1. My check is, are both my brackets the same? So yes, they are. So we'll take that out, x minus 1, and leaving us with x plus 3. So now we fully factorised the top and we fully factorised the bottom line. So let's put them back together. So in the top line, we had our answer here. In the bottom line, we had our answer here. So we've just put them back together. And as you can see, when we put them back together, both above and below the line, there is an x plus 3. So these can be cancelled. So because they're common above and below the line, we can cancel them out. This leaves us with x bracket x plus 4 over x minus 1, and we can multiply back out that top line, which gives me x squared plus 4x over x minus 1. So that is the simplifying algebraic fractions, and this is the most likely way that you will be asked your factorization as part of a question. It doesn't mention anything about factorization. You have to know that you have to do factorization in order to simplify the fraction. So this next example, we're going to look at adding and subtracting algebraic fractions. So a similar method is used for both. In this example, we have both adding and subtracting. So we're going to use a common denominator. So in order to add or subtract any fractions, you need to have a common denominator. The first thing we're going to do is we're going to look at the denominators that we have. So we have an x plus 2, we have an x minus 3, and here we have a quadratic. And so the first thing we're going to do is we're going to take this quadratic. So we have our x squared minus x minus 6. We're going to use our guide number method to try figure out what my factors are. Okay, so let's rewrite this. X squared plus 2x minus 3x minus 6. X is common here, so we have an x plus 2. Minus 3 is common here, and we have an x plus 2. The check is, are my brackets the same? Yes, they are. So I can pull those out because they're common, and that leaves me with an x minus 3. So actually, if we want to rewrite this, we have 1 over x plus 2 minus 3 over x minus 3 plus 4 over x squared. No, apologies. So this time we're going to rewrite this using the factors we've just found, which were x plus 2, x minus 3. So now we're going to get our common denominator. So we're going to look for what's called our lowest common multiple of x plus 2, x minus 3, and x plus 2, x minus 3. And hopefully you can see that using these two factors here will create a common denominator for us because they contain the x plus 2 and they contain the x minus 3. So our lowest common multiple is x plus 2x minus 3, and that is the common denominator. Okay, so let's take a look what this looks like for us, x plus 2. So if we want our common denominator to be x plus 2x minus 3, what we're missing here, we'll put it in green, is an x minus 3. And I don't want to change my fraction, so whatever I do to the bottom, I'll also do to the top. Then I come along, I have my minus 3 over x minus 3. This time what I'm missing is my x plus 2. So again, whatever I do to the bottom, I do to the top. And now my last fraction, there's nothing that I need to do since that common denominator is already there. Okay, so now I have three fractions, all have the same denominator, so all have the common denominator. I'm now going to combine them. So I have 1 bracket x minus 3. Be really careful, we need this negative here, so minus 3 x plus 2, and that's plus 4. And now what we've done is we're going to combine these fractions. So instead of writing the same denominator 3 times, we're just going to write it once. So we have an x plus 2 and an x minus 3. And now I just need to tidy up. So in the top line, I have x minus 3 minus 3x minus 6 plus 4. And that's all over x plus 2. X minus 3. So now we'll see what do we have in common. So we have an x here, we have a minus 3x, and then we have a minus 3, a minus 6, and a plus 4. So an x minus 3x gives me a minus 2x. Minus 3 minus 6 gives me minus 9. Plus 4 gives me a minus 5. And that's all over x plus 2, x minus 3. So if at this point you want to multiply out the bottom line, that's absolutely fine. We already know that it's equal to this, so we can just rewrite that. So minus 2x minus 5 all over x squared minus x minus 6. So the third example we're going to look at is where we are multiplying algebraic fractions. So in order to multiply fractions, we multiply across the top and we multiply across the bottom. Okay, there's no need for common denominators. There's no need for any changes really. Although factorizing, if we can make our lives a little bit easier. So you'll notice that anywhere we can factorize, we are factorizing because that will help us see. It will help us to see if there is any cancellation that can happen. So the first thing I'm going to do is I'm going to label my line here. This is my top line here, and this is my bottom line. So let's deal with those slightly separately. We'll deal with them over here, top line. So my top line here is x squared plus x minus 2. So my guide number here is minus 2. So if I have this as a plus 2 and a minus 1, I'll be able to rewrite this as x squared minus x plus 2x minus 2. So my x is common in the first instance, so x minus 1, and a plus 2 here, x minus 1. So my check is, are both my brackets the same? Yes, they are, so they're common, so let's pull them out. And x plus 2. So that's my top line factorized. So let's look at the bottom line then. So my bottom line is x squared plus 2x minus 3. My guide number here then is minus 3. So if I have a plus 3 and a minus 1, that will add up to plus 2x, exactly what I want. So we'll have x squared minus x plus 3x minus 3. And we'll take out the x in the first instance and a plus 3 in the second one. And our check again is, are my brackets the same? Yes, they are, which is great. And then I'm left with an x plus 3 here. Okay. So now let's put it back together. So here I have an x minus 1 and an x plus 2 all over an x minus 1 and an x plus 3. And I'm going to be multiplying that by 2, apologies now, 2x plus 6 over 4x minus 4. So remember our rule is multiply across the top. So to show multiplication, we're just going to use our brackets. So we already have x minus 1, we have an x plus 2. We're going to multiply that by 2x plus 6. On the bottom we're going to have an x minus 1, an x plus 3, a 4x minus 4. So at this point you might see that we actually do have an x minus 1 above and below the line. So we can simplify that. Okay. So now what we're left with is an x plus 2, 2x plus 6 all over x plus 3, 4x minus 4. Okay, so you might notice now that there is a 2x plus 6 on the top line, which actually could be factorized, and a 4x minus 4 on the bottom line that could be factorized. And they can both be factorized by taking out a common factor. So here, the common factor of 2x plus 6 is 2. So we'll take out a 2 and we're left with x plus 3. And on the bottom line, we can take out a 2 here as well. So we have an x plus 3. We take out a 2 and we're left with 2x minus 2. So what you might notice now is we have an x plus 3 common above and below, and we have a 2 common above and below. So our final answer then is going to be x plus 2 over 2x minus 2. So if you wanted at the very start to factorize both of these as well, that would be absolutely fine. Often I think people can really quickly see that there's a quadratic that needs factorization, but maybe won't see the easier ones, like something apologies, like something that is common. So what I've shown you here is how you can deal with that if you see it later on in the question. There's no issue. So example 4 is dividing algebraic fractions. So division is really important when it comes to fractions because we use something that's called the reciprocal. Now you would have encountered the reciprocal back in primary school when you did division with fractions. However, maybe you didn't use the word. So we will see this word in other places, so it's a good word to have. And what that means is basically the fraction is turned upside down. Okay, so in the most basic example, if you want to get half of something, and I'll just give you an example. So if I want to get half of 10, it's half multiplied by 10, which gives me 5. Using the reciprocal of that, so we can have 10 divided by 2 over 1, which is just 10 divided by 2 will give me the same thing. So in order to help us, we're going to use the fact that to divide by a fraction like here, we can instead multiply by its reciprocal. Okay, so in order to divide by a fraction, we can multiply by its reciprocal. So I'm just going to get rid of that there. So in this example, we're dividing by 4 over 4x squared minus 1. So we're going to use the reciprocal. So what this becomes, so straight away, 2x minus 1 multiplied by 4x squared minus 1 over 4. Now, it becomes much easier because we can now use our rules of multiplication, multiply across the top line, multiply across the bottom line. Like in the last example though, it might be better for us to do a little bit of factorization first. So we have a 4x squared minus 1. You should be able to see that factorization here is the difference of two squares. So it's going to be 2x to be squared minus 1 squared, which gives me 2x plus 1, 2x minus 1. Okay, so let's put those back together. So we'll have 2 over 2x minus 1 multiplied by 2x plus 1, 2x minus 1. And to help us, we can even factorize the 4, which is 2 by 2. So now, let's do the multiplication. So again, remember, multiplication is just shown by brackets. So we're just putting our brackets next to each other. Here we'll have 2x minus 1, 2 by 2. So hopefully at this point we see that there are some things in common both above and below the line. So 2x minus 1 and a 2x minus 1 and a 2. So what we're actually left with is 2x plus 1 all over 2. And we can actually simplify that further. So this is the same as 2x over 2 plus 1 over 2, which can be simplified to x plus a half. Okay, so it's really, really important to remember that we can use what's called the reciprocal when we divide. So instead of dividing by a fraction, we can multiply by its reciprocal, and then we work through any question like it was a multiplication question. Now, example 5 is basically simplifying a complex fraction. So as you can see by this, it is quite complex. We have fractions within fractions. So like we've done before, the easiest method is really to split this out into top line, bottom line. So there's not a lot we can do with the top line, it's a plus b, but there is a little bit we can do with the bottom line. So let's look at the bottom line here. We have 1 over a plus 1 over b. So we need to add these. So we're talking about common denominator, which is basically the lowest common multiple of a and b, and that is ab. So 1a, and we're going to have a b here as well. So the top line we're going to multiply by a b. Okay, and then along we come to this one. So we have a b on the bottom, so we're going to include an a on both the top and the bottom. So we get b plus a over ab. Okay, so now let's go back to our fraction. We have a plus b all over b plus a divided by ab. Now, if you can remember that in a fraction, that middle line here means divide. So think of a fraction 1 over 2, 1 divided by 2. So think of that as a division line. We can write this in the form of a plus b divided by b plus a over ab. From the last example, we know that if we want to divide by a fraction, we can instead multiply by its reciprocal. So that's when we turn the fraction upside down. So it's going to be multiplied by ab over b plus a. To help us out, we can put this over 1. Okay. So what that looks like for us, we're going to multiply across the top a plus b by ab all over b plus a. Now, if you look here, we have an a plus b and a b plus a. They are written in different ways. However, both the a and the b are positive, so they are equal. So these can be cancelled, and that leaves us with just a b. So when you've complex fractions, really we're going to simplify the fractions as much as we can, and then we're going to create a division. So remember that that fraction line is a division. We will be looking in another video about long division. So often those questions are also written as fractions, and you will recognize those because you cannot do any type of factorization and cancellation like we have done in these questions. So the final example we're going to look at is actually an exam question. So they've given us an f of x, they've given us a g of x, and they've said if f of x divided by g of x equals ax plus b, find the value of a and b. Now, I really just want to talk about these bits here. So here it's told me that x does not equal plus or minus 1, and here it tells me x does not equal minus 1 and 2. Now, that is important for us because if we come up with that answer, it's incorrect. However, in this particular question, we're only looking for the a and b. We're not looking for x. So it seems irrelevant. However, to ensure that the question is mathematically sound, to ensure that nothing will go wrong with the question, they have to include this piece. Because what will happen if x is plus or minus 1, so plus 1 squared will be 1, minus 1 squared will be 1, so both cases it'll be 1 minus 1, leaving 0 on the bottom line. And it is important to note that you cannot divide by 0. It is not possible. If you want to try it out on your calculator now, if you want to pause the video and go get your calculator and try, put in 10 divided by 0, you will get an error. It does not work. So similarly over here, if x was minus 1 or if x was 2, it would mean that this whole bottom line is 0. And again, it would be an error. It's not possible. So just not to get confused when you see these extra bits there, it's really to cover themselves. For us at this point, given what we've been asked to do, it really is not relevant for us because we're not being asked to find an x. Sometimes bits like that can confuse people. So hopefully now you won't be as confused when you see it. So now we want to have fx divided by g of x. So let's start. We'll have x cubed minus 1, x squared minus 1, and we're going to divide that by x squared plus x plus 1 over x squared minus x minus 2. Okay, so what we know is instead of dividing, we're going to use the reciprocal. So we're going to flip the fraction. So instead of dividing by this fraction, we're going to multiply by its reciprocal. So what that means is we're going to flip it upside down. And now we're going to multiply. So multiplying we can deal with. Now, before I go any further, I'm going to actually go and do some factorization. So I'm just going to label these just to help me. So let's look at number 1 here then. So we have x cubed minus 1. Hopefully you remember your formula for the difference of two cubes. It's a minus b, a squared plus ab plus b squared. If you're not sure about it, there is a video done on factorization that you can go back and look at. So what that means for us is we're going to have x minus 1, x squared plus x plus 1. Okay? So you might look at this and say, oh, it's quadratic, I can factorize. And you could try, but you will find that the guide number won't work. if you were to solve it, we'd have to use minus b, but we're looking factorization, so there's no easy factors for us to get. So let's look at number 2 then. We have a difference of 2 squares. Again, hopefully you remember your formula. A squared minus b squared gives me a plus b and a minus b. Okay, so for me this is x plus 1 and x minus 1. Now let's look at number 3. So we have x squared minus x minus 2. So my guide number here is minus 2. So this will be plus 2. Apologies now. So it's going to be minus 2 by plus 1. So we will have x squared plus 1x minus 2x minus 2. So we have x plus 1 minus 2 gives me x plus 1. And my check is, are my brackets the same? Yes, they are. X plus 1 and x minus 2. Okay, and then last but not least, we're going to have number 4. And for us, that's x squared plus x plus 1. And if you try to go and find, so your guide number is plus 1. There are no factors of 1, so my factors of plus 1 are either going to be plus 1 and plus 1 or minus 1 and minus 1. And there's no way that will add to x, so they can't be factorized. But that's okay. So I'm just going to put in let's just put in a line here. So let's go back. So 1, we're going to write it as x minus 1, x squared plus x plus 1. We're going to have x plus 1 and x minus 1 on the bottom of that fraction. And then you multiplying that by, what do we have for 3? We have x plus 1, x minus 2, and that's going to be over x squared plus x plus 1 that we couldn't factorize. So let's combine that. So we have an x minus 1. We have an x squared plus x plus 1. We have an x plus 1 and an x minus 2. So here's our x plus 1 on the bottom, x minus 1, and it's just being multiplied by my x squared plus x plus 1. Now, so if we want to see what we have both above and below the line, so there's an x plus 1 and an x plus 1, an x minus 1 and an x minus 1, an x squared plus x plus 1, and x squared plus x plus 1. So that leaves me with just an x plus 2. Okay. So if I just move up here, so f of x divided by g of x gives me x plus 2. And they told us that it will be in the form of ax plus b. So therefore, a is equal to the number in front of x, which is just 1, and b is equal to the constant, which is 2. So just be careful. This here is a correct answer, but it's not really the correct answer to what we were asked. So do remember, what am I being asked? Okay, so apologies, this has gone a bit messy down here. So if you were laying this out on your copy, maybe rough work to the side, you'll have more space than I have here. Just to remember that you're constantly using your factorization to simplify these fractions, and it is easier to do it at the end. It's really important to remember that when you are doing your simplifying or your dividing, it can only happen when everything is in brackets. So when everything is broken down into factors, you cannot cancel otherwise, because cancelling is actually dividing, and it can only happen when there is multiplication there.